Hello there. My name is Michael Cadger. I am in Computer Science 412 Cloud Computing, and this is my video demonstration for Project 2. As you can see, I have my Doxygen annotation up here, just showing off the classes that I have for my project, but let's go ahead and get into the code. So we pull it up here. I have 3 header files, request.h, webserver.h, and loadbalancer.h, as well as load balancer CPP, request.cpp, and webserver.cpp. These are all called and compiled through the main.cpp file. And so let's go ahead and describe a little bit of what goes on here. We have webserver.cpp, which actually we're going to start with request.cpp because that's the simplest one, and that's the basis of everything. So request.cpp generates a request with a random IP address for its input and its output, as well as an incremental ID that is assigned to it as well. And it also is given a random time value, which is how long the request would take to process, anywhere between 1 and 200 clock cycles. All right, and so next we have webserver.cpp, which is a web server that handles requests. It has 3 attributes, being Boolean busy, the current request that it's working on, and how much time is remaining on that request. These web servers handle requests. When they're not busy, their busy value is false. As soon as they get a request, they're busy, their current request is assigned, and the amount of time they have is this randomly generated time from the request itself. Next, we have loadbalancer.cpp. Load balancer class has 3 values. Uptime, which is how long we want it to run for. We have request queue, which is the queue of the requests that are waiting to be handled by web servers. And we have a vector of web servers called server list, which is the list of all the web servers that we have allocated and that are set to be working on requests. We enqueue the different requests into the request queue using the queue function. And our main function here is void load balancer start. This is just starting the load balancer. So it essentially will iterate through the server list continually until it reaches the desired time that you want it to run for. It goes through the server list, checks if each server is busy. If it's not busy, it assigns the next request in the queue to it. If it is busy, it just keeps on working on that request. Later, we have, every time it goes through the while loop, we have a 1 in 100 chance of assigning a new request to the end of the request queue. And this increases the size of the request queue. So in main.cpp, this is where it all comes together. We ask the user how many servers they want to run and how long they want the load balancer to run. We're going to minimize this for the second. How long we want the load balancer to run in terms of clock cycles. Then we do some declaration of stuff. And so we multiply the number of servers that you want by 100 to get the size of the request queue that we want. And then we generate random requests for the request queue. And then we also generate web servers for the server list. Then we use the start function that we saw earlier from load balancer to start the load balancer. And after we are finished with the load balancer, we check the request queue, see if there's anything left in it, and print it out. So I'm going to go ahead and uncomment these lines, which are just going to show us that we have however many queues in the request queue that we ask for. Let's go ahead and run this. So we hit run. It asks how many servers would you like. We're going to say we want 10 servers. Then it asks how long do you want the load balancer to run. We want it to run for 10,000 cycles. And we're going to hit enter. And so it seems like that request finished. Let's go ahead and scroll up. Initial request queue ID, so this is just the initialization. So the first request in the queue is request ID 1. It goes all the way down to 1,000 because that's 10 times 100, as we said earlier. And then down here we have the requests that are in the queue when we finish. And so we have 96 in the queue once we're finished. So over the 10,000 clock cycles, our load balancer reduced the size of the queue from 1,000 requests to 96. And that's about all that we have for you today. Hope you have a great rest of your night. And my name is Michael Cadger. You have a great one. Bye-bye.